All right, welcome. This is the week 3 of the distance learning packet for IM2. Here we have page 1 and 2. All right, so before we start on this, I want to give you some of the notes and core concept that you're going to need to be able to do these problems. First of all, you want to talk about what a domain of a function is and what the range is. The domain of a function is the set of all possible inputs, and you want to take a look at this word. It's very important, the word input values. Sometimes you might see this as your x value sometimes, and then the range is referred to as your set of all possible outputs, and your output graphically, that is going to be your y value. Okay, there are two types of functions here. You have this graph A, which is going to be considered discrete. What do I mean by discrete? Is that there are dots. Okay, so what you can write here is that this is a discrete graph. All right, and what you have here is going to be a continuous, mind my spelling, it might be wrong, continuous graph. Continuous. Okay, that looks right. Continuous graph. Okay, so these are two. Discrete is because there's gaps between these dots. The continuous, it is smooth and continues forever. There's no gaps, right? The domain here is you're looking at the x values, okay? So what you can see here is that the x value of this dot would be x is equal to -1. X is equal to 0 for this dot. X is equal to 1 for this dot. X is equal to 2 for this dot. This is why the domain is listed as -1, 0, 1, and 2. Okay, the y's, the y here is going to be y2, here y0, y -2, and here y is equal to -4. Here they just wrote it in least to greatest, so the range here is -4, -2, 0, and 2. Okay, that's how they list it out. But here, this is a continuous graph. Notice it starts from here, from this point. The x value here is going to be -2, and the y here is going, no, sorry, that's not -2. That is going to be, that is x is equal to -3. The y is going to be -2 here. All right, so then it goes all the way to this value. The x value here is going to be 3. The y value here is going to be 2. Okay? All right. So it goes all the way for the x. Do you see how it goes all the way from -3 to 3? That's what they wrote here. Okay? And then here, the range, it goes from -2 all the way to 2. Okay? The inequality will always behave something like this if you go from least to the greatest. Okay, if you follow this format, it's always one of these. Okay, remember this means to include, okay, but this means to not include. All right, okay, some reference if you would like. So a dot means to include. Okay, this is close, this is referred to open, and this is when to not include. All right, so let's use this information to do the first problem. All right, so Sue hits a ball from a height of 4 feet. The height of the ball above the ground is a function of the horizontal distance. The ball travels until it comes to rest on the ground. Consider this complete graph of the function. Here's the trajectory of the ball. The question is just asking you for all the values of the domain. Remember what the domain refers to? The domain refers to as all of our x values If you look at our x values, it's right here. It goes from all the way to this value, which is x is equal to 0, all the way to this value. Do we know this number? Well, we know that each one of these goes by 20. So if this is 180, this is going to be 200, right, for a reference. So let's see if these all make sense. First of all, can x be -5? X is -5 is somewhere here. Nope, this is impossible. This wouldn't work. Can it be 0? Does it touch 0? Yes, it does. It touches x is equal to 0 right here. So we would say that works. X equals to 60, does that work? Does it touch at x equals to 60? Yes, at that point x does equal to 60. And that's x equals to 220. 220 is right here. 220, does it touch it? No. So we would say no. All right. These are all the values that it would work for this graph. Okay. So think about the ball being shot from 0 and it goes all the way to 200 feet. All the distance here is its distance that the ball travels. It can never go to -5 feet and it can never travel to 220 feet. It stops here at 200 feet. All right, so we look at this problem here. You're going to identify the domain of this function. All right, and the domain is, again, like what we talk about as your input values, also consider as your x values here to use for the modeling this content. Okay, so an interval of all real numbers and a subset of the integers. An interval of all real numbers, so this could be any number, and this is just a subset of the integers. Okay, so the total value of f of x in cents of a handful of x dimes and 1/4. Okay, so think about the input here. The input is a handful of dimes. This, okay, you can only have 1, 2, 3, 4, 5. Okay, so this is only whole numbers, right? So this would work. Okay, these are physical whole numbers if you wouldn't think about it. Physical numbers. Here it wouldn't work. Here this is like having a half. Okay, you can't do that. Okay, the amount of water of x in a tank that starts with 25 gallons being filled. So this is the amount of water. All right, so here's the question. Can you have a physical number of water? Yes, you can. Okay, you could have 1 gallon. You could have 2 gallons. Right? That would make sense. Okay, now here's the question. Can you have half of a gallon? Yes, you can. Because you could cut it and it's still a gallon, right? In this case, can you have half a dime? Like, can you cut physically a dime in half? No, it's no longer a dime. All right. A lot of you are saying, hey, it could be 5 cents. Yeah, but it's not a physical dime though. Okay, the essence of the object gets ruined. Right, so here, the last one, the total money raised, f of x, if x people donate 10, the total money if x people, ooh, look, very carefully here. It says x people. These are people. So, can you have one person? Yeah. Can you have 2 persons? Yeah. Okay, so yes, you could have a physical number of them. Can you have half of a person? All right. Can you cut a person in half and can they still donate? No. Okay. So this wouldn't work. So this is X people. All right. So what you're looking here in this question is understanding domain. Okay. Can domain be physical numbers like 1, 2, 3, 4, or negative like -1, -2, -3, or can they be the subset, right? What they're talking about here is like integers or decimals, like 1/2, 3/4, right? 0.5, 0.75, or pi, right? Things like that, okay? So just think about physical complete numbers, which are like integers, and then everything else there, okay? Let's look here at number 3. Okay. All right. The graph shows the population of the mice in the study model as a function of time. The study begins one day, 0, and ends on day 20. Okay. So here, I just want to label this information that this is when it is on what? The day 1? No. Yeah. Day. So this is day 0. And this is going to be day 20. Okay. So what's the exact question? Determine whether each statement is true according to the graph. Okay. The mouse population was decreasing before between day 40 and day 80. So how much are they going up by? So this is 100. So this is 20, 40, 60, 80, 100, 120, 140, 160, and 180. I just wrote it just to make sure I see the numbers. Okay. So let's see if it makes sense here. The mouse decreases between day 40 and day 80. So where's day 40? Day 40 is up here, right? So this is day 40. And we are looking also at what? Day 80. Day 80. Is it decreasing? Yep. This does have a negative slope. Right? So we would say that is correct. Let's look at the next one. I'm going to make that green. The least number of mice during the study was 130. The least is referred as your minimum of the day was 130. Is that the smallest value? So let's see. Well, where's the smallest? I see it right here. And I see it right here. Is that reasonable? Hold on. How much is this going up by? 1, 120, 140, 150? No, 100, 120, 130, 140, 160. No, wait. 100, 120, 140. Yeah. So this is 140, 160, 180, 200. Okay. Is this 130? Yeah. Hold on. Is it the smallest 130? To be honest, this looks like 120, but this does look like 130. I would actually say false because I think the smallest, the least, is actually 120 at day 200. Okay, right there. You could make the argument for 130, but 120 looks smaller here. Okay. There are two intervals of the time where the mouse population is decreasing. Okay, so we have one interval right here, day 20, day 40 to day 80, where it is decreasing. Then we also want another interval where it's also decreasing. So this is positive slope. Oh, here it looks like this is also negative slope from day 160 all the way here to day 200. And we would see that this is decreasing. Yep. So I would actually say this is true. Oh, we missed one. The mouse population is greatest at that number. So greatest, this is referred as your maximum. And let's see if 160 makes sense. Is that its highest value? So go up. Right here, this is its highest value. The mouse it's day 160, but what is its mouse population at that? So this is day 160. Its mouse is 180. So is that correct? The mouse population is greatest at day 160. Yes, that is actually correct. At day 60, that is correct. At day 60, it does have the greatest amount, with mouse being 180. Okay. Right. Good. So now let's look at number 4 here. Billy's buy light bulbs in packs of 8 for $20. The shipping cost is $10. Regardless of the number of packets bought, Billy has only $120 to spend. If N is the number of packets of light bulbs bought, and then the cost per light bulb, C, can be modeled as a function of N. Select the statement that correctly describes the domain of the function. All right, so the domain of the function is what your plugging in. And what we have here is that it literally says that the end is the number of packets of light bulb that can be bought. Okay. All right. So these are physical numbers, right? This is very shady. These should not be these are all in interval notations. The set of all integers. Okay. They say all integers, so okay. And the domain is all set of all real. Ooh, no. Bad. So let me just, okay, I will talk about this in a bit. So the shipping cost is 10 regards the number of pot, and he has, okay. So he has a total of 120 to work with, right? This is his total amount of money. And he has to pay for shipping. So this is negative $10. He has to lose, right? He has to pay for $10 shipping. And then he has to buy a pack of light bulb for 20 bucks. Each pack is $20. Okay? X. So these are, X just represents the numbers of packs that he can have. Okay, so this is still cost. So hold on, this should still be plus. All right. So originally, what you need to do mathematically is that you want to subtract this over, show the shipping costs. Right. So you're going to subtract the shipping costs to both sides. So in reality, he only has $110 to spend. Okay. Because this is the amount of money he has to buy packs after shipping costs. After the shipping costs. Okay? All right. So, packs of, let's see, and each of them is 20 bucks. So how much can he buy? Well, he can buy one, right? Which is 20 bucks. Okay, so this is one. He can buy two, which is going to be 40 bucks. Then he can buy three, which is 60 bucks. He can buy four, which is 80 bucks. Then he can buy five, which is at 100 bucks. Can he buy six? No, he cannot buy six because this would be, right, 120. Okay, he cannot buy the 6-pack. So he could buy one pack up to the 5th pack. So what you can cross out here is you can cross out this because it says 1 through 6, and you could say 1 through 6 here. Okay, so the difference is this word, okay? Is this statement. Is this statement. Set of all real. And these are just set of all real, set of all integers. So this, when it says this, all set of real from 1 to 5, this includes, okay, this includes like 1.5, 2 over 5, 4 over 1, right? No, these are just these are like just integers. So 1, 2, 3, 4, 5. Okay. All right. So it would be this answer. Okay. Because you can't have half of the packet. You can only have full numbers of packets. Okay. And I think that's it. Do we have any more? No, that's it. So here you go. I decided to give you all the solutions for this page because they're a little bit more harder problems. Okay. But there you go. Here are your core concepts if you just need it. All right. There you go.